January 27, 2025. Seismographs northeast of Santorini begin recording, and they do not stop. In 15 days, more than 15,000 earthquakes are logged between Santorini and Amorgos. By the end of 30 days, that number exceeds 30,000. A density of seismic activity never previously documented in this region. The Greek government declares a state of emergency. Schools close. Residents are told to drain their swimming pools. The movement of water during tremors could bring down buildings. Around 11,000 people leave the island voluntarily. 3.5 million tourists visit Santorini every year. In late January 2025, the island they were planning to visit was being evacuated. But here is what the headlines did not explain. The earthquakes were not coming from Santorini. They were coming from 7 kilometers offshore, from a submarine volcano called Colombo. A volcano sits 500 meters beneath the surface of the Mediterranean, a volcano most people have never heard of. And when scientists published their findings, what they found beneath that seafloor changed the risk assessment for this entire region. When most people think about volcanoes, they picture a mountain, lava flowing down a slope, a visible threat. Beneath the oceans, there are far more volcanoes than exist on land. The difference is that we cannot see them. Most of them we have never properly mapped, and some of them sit directly beneath some of the most densely visited coastlines on the planet. Colombo is one of those. It sits 500 meters below the sea surface, along the Hellenic volcanic arc, the same geological zone where one of the largest eruptions in recorded human history took place. The eruption of Thera, around 1600 BCE, effectively ended the Minoan civilization. The last time Colombo itself erupted was 1650. Pyroclastic flows crossed the sea surface and reached the shores of Santorini. Toxic gases spread across the island. 70 people died. Since then, silence. Nearly 400 years of silence. And on a volcano, silence does not mean nothing is happening. It means you cannot see what is happening. In October 2022, a study published in the journal Geochemistry, Geophysics, Geosystems changed what we know about what is building beneath Colombo. The research team, led by geophysicist Kajetan Trapkevich at Imperial College London, used a technique called full waveform inversion. It works similarly to a medical ultrasound, but applied to the seafloor. A research vessel fires sound waves into the ocean floor. Those waves travel through solid rock at high speed. When they hit magma, the speed drops sharply. By mapping those speed differences across an area, scientists can build a detailed image of what lies beneath the surface. It is, effectively, an X-ray of the Earth's interior. What the image revealed was a magma chamber that no previous method had ever detected. It extends from 2 to 4 kilometers below sea level. It spans approximately 600 meters in width, and the total volume of accumulated magma inside it is 1.4 cubic kilometers. That is enough to fill more than 500,000 Olympic-sized swimming pools, with molten rock at temperatures exceeding 1,000 degrees Celsius. But the volume is not the most alarming part. According to the study, this chamber has been growing at an average of 4 million cubic meters per year since the last eruption in 1650, every single year, without stopping, for nearly 4 centuries. Krapivich himself stated that if this rate continues, Colombo could accumulate 2 cubic kilometers of magma within the next 150 years. That is the estimated volume expelled during the 1650 eruption. The volcano is recharging itself toward a repeat of the event that killed 70 people on an island with a fraction of today's population. The authors were direct in their assessment. The characteristics of this system indicate a highly explosive eruption, comparable in style, though lesser in magnitude, to the Hunga Tonga eruption of 2022. That eruption generated tsunami waves up to 20 meters high and an eruptive column that reached the stratosphere. Colombo sits 7 kilometers from an island that receives 3.5 million tourists per year. January 27, 2025. An earthquake swarm begins approximately 10 kilometers northeast of Santorini, directly in the region of Colombo, and it does not stop. Over the following 30 days, more than 30,000 earthquakes are recorded between Santorini and Amorgos. The University of Athens reported over 15,000 quakes in just 15 days, a density of seismic activity never previously documented in that region. The largest individual tremor reached magnitude 5.2. The Greek government declared a state of emergency on Santorini between February 6 and March 3, 2025. Schools closed. Residents were instructed to drain their swimming pools. The movement of water during tremors could destabilize building foundations. Around 11,000 people left the island voluntarily. Then came the explanation. In November 2025, a study published in Nature provided the data behind the crisis. And what the researchers found was more significant than the earthquake swarm itself. Santorini and Colombo, two volcanoes that had always been treated as separate systems, are connected. They share a deep magmatic reservoir beneath the crust. The data showed that gradual inflation of the Santorini caldera, which began in mid-2024, preceded the intrusion of a magma-filled dike sourced from a mid-crustal reservoir beneath Colombo. The research team analyzed more than 25,000 earthquakes using artificial intelligence and concluded that sheets of magma had sliced through the crust at depths greater than 10 kilometers, covering an area of approximately 20 kilometers. The volume of magma involved in that single intrusion was enough to fill 200,000 Olympic-sized swimming pools. It did not reach the surface this time, but the movements recorded during the crisis made clear what was happening in real time. The seafloor above Colombo sank by as much as 32 centimeters. The surface of Santorini rose by more than 10 centimeters. Magma redistributing between two volcanic systems simultaneously, in opposite directions, in response to the same deep pressure event. Two volcanoes, 7 kilometers apart, breathing together. Scientists stated directly that this interaction between the two systems significantly increases the risk of future activity in the region. Every risk model built on the assumption that Santorini and Colombo were independent now needs to be rebuilt from the ground up. Colombo is not the only submarine volcano in the Mediterranean that deserves attention. Marsilli sits in the Tyrrhenian Sea, approximately 175 kilometers south of Naples. It is 70 kilometers long, 30 kilometers wide, larger than Mount Etna. It rises nearly 3,000 meters from the seafloor, with its peak sitting just 450 meters below the surface. Almost nobody has heard of it. The Italian National Institute of Geophysics and Volcanology has warned that Marsilli has structurally unstable walls fed by a shallow magma chamber. Simulations by the University of Bologna showed that a partial flank collapse would send tsunami waves reaching the Aeolian Islands in approximately 10 minutes and the coasts of Calabria and Sicily in 20 minutes. In the most extreme modeled scenario, waves up to 20 meters high would hit the coastline. The Mediterranean has no robust tsunami warning system. The distances between a submarine volcanic event and a populated coastline are short. The reaction time is measured in minutes, not hours. In December 2025, the research vessel Meteor departed on the Multimar expedition to Santorini, specifically to test new submarine monitoring systems designed for exactly these kinds of hidden volcanic systems. The Santorini Observatory has been monitoring Colombo continuously since December 2022. New seismographs were installed inside the volcano's crater during the 2025 crisis. The pace of discovery has accelerated sharply. Our understanding of what is building beneath the Mediterranean has advanced more in the last 3 years than in the previous several decades. Every new instrument, every new dataset, makes the picture clearer. And what the picture shows is this. Beneath one of the most visited bodies of water on Earth, two connected volcanic systems are accumulating pressure. One of them has been growing its magma chamber for 400 years without releasing it. The other experienced an intrusion large enough to deform the seafloor by 32 centimeters in a single event. The magma did not reach the surface in January 2025, but the instruments recorded exactly how close the system came to finding a way through. Subscribe to stay with this story, because the data keeps coming and the Mediterranean is not finished.